So I'm Marc Weber, Curatorial Director of the Internet History Program at the Computer History Museum, which is quite a mouthful. But I've been researching the history of the web and later networking since the mid-1990s, starting at CERN in Geneva, interviewing the original web team. And in terms of software, obviously this has been, a challenge since the beginning, because even back then, things that were online were hard to preserve. As Pierre Mounier-Kuhn said, we have 10% of the classical literature with software. I don't think it's even that good. And, I tend to work off a diagram of kind of what are the important online systems and networks. And it's very few that we have well-preserved and accessible software. I also curated a good portion of our software exhibition, where I'll talk about it later, but we're showing case studies of software, because software itself can be quite abstract to communicate to the public. So that's me.
Okay, now it's Hansen to turn. Welcome, Hansen.
Hi, I'm Hansen Su. I'm a curator at the Computer History Museum. I'm part of the Software History Center. Yeah, and I guess that's all I'm. That's it.
That's it. Okay, thank you. And Claire Fox, Emulation-as-a-Service infrastructure.
That's right. Hi, everyone. My name is Claire Fox. My pronouns are she, her, and I am a digital preservation librarian at Yale University Library. And many of you probably attended my colleague Ethan Gates' presentation earlier about EaaSI, about the Emulation-as-a-Service infrastructure program of work. For those of you who didn't, just to give a very quick summary, EaaSI is both an access platform that provides access to legacy digital collections via the use of emulators. And it is also a network of institutional partners and affiliated professional organizations like the Software Preservation Network, who we heard from yesterday, who all aim to share resources, including legacy software and expertise in service of working collaboratively on the challenge of software preservation. So my primary task at Yale is to support what we call the Yale Node. EaaSI as a program of work is hosted at Yale, so that opens up a lot of possibilities for building and testing resources, both within EaaSI itself, again, as a program of work, and in service of providing access to Yale's born digital collections. So one of the main ways that I currently do this work is by supervising a workflow that aims to create pre-configured emulated computing environments in the EaaSI system, and then document those environments by gathering key metadata about them. And these environments are all created on Yale's production instance of EaaSI, which is a little different from the one that Ethan demoed earlier. And a curated set of these environments will eventually be published and made available to the larger EaaSI network of affiliated institutional partners. This work is conducted by a team of undergraduate and graduate student workers at Yale who are from a range of different departments and disciplines, and also levels of technical proficiency. So today I'm looking forward to this conversation, like wherever it may go, but I feel as though I am primarily here offering the perspective of someone who works with students and who are doing this critical software preservation work, and also as someone who creates and performs quality control on metadata that is used and reused for a few different purposes in the realm of digital preservation.
Thank you very much, Claire. So I'm going to go on with the list. So Kat, please introduce yourself. I know you just talked, but again, we have people attending from the US, and sometimes depending on the coast, they just joined us. So please, Kat.
I'm Kat Thornton. I'm the co-founder of ScienceStories.io, and along with Kenneth Sealsnut, we created a software stories platform for software heritage software stories. And my relationship to software preservation is interested in making it easier for people who may not know anything about software to explore multimedia stories related to software and software source code so that they can learn more and hopefully become inspired to help preserve more legacy software code.
Thank you. And now we're back to Tom Haigh from University of Wisconsin, Milwaukee and Siegen University. So please, Tom, introduce yourself and your relationship with software preservation.
Hi, yeah, so I have written on a number of aspects of the history of computing. The one that's most relevant is probably this book, ENIAC in Action, and its supporting website, eniacinaction.com. And that is the main and essentially only, I think, example of a professional historian integrating the analysis of code into a work of narrative history. The online supporting materials have the code for what we believe is the first modern style computer code ever written by Clara von Neumann in the 1940s. And it's also the first Monte Carlo simulation ever run on a computer. I also have been teaching the history of computing recently and put together a lab full of computers from the 80s and 90s. So that in a sense is another approach to software. And in many ways, I think you learn a lot more from running the software on the original machines than you do from emulating it, because the affordances and the materiality are so different. So I have some thoughts on this business of saving code, what groups of people might benefit from it, and how that might shape up in the future. And I'll be happy to share those later in the discussion if there's an opportunity.
Yes, of course there will be, because you covered some of my questions. So I will start from you, actually asking something that is, I'm taking you as a kind of representative of the historian. So one of the idea of this roundtable and of these 2 days is to have moment of reflection about software preservation that can involve different actors involved in software preservation, from digital preservation experts to people really involved also in displaying software, like museum curators. But also I kind of feel that there is also a need to talk also to historians. So the first question I'm going to ask is to you, but this is going to be just the first part of my question, and then it's going to involve the others. So what is that historians could do to better support software preservation? But the second part of my question that will go to the others is what the others, so museum curators and digital preservation experts, or people like Kat and Kenneth, can do to support the work of historians. So first, let's start with Tom.
I don't think historians can do much to support the work of historical preservation. I think the question should be the other way around, right? Because why are we preserving this code? Presumably so that somebody is going to do something with it at some point. So the question is, which people and to do what? So one group that's obviously got an interest are retro computing enthusiasts. There's actually a much, much larger community than the community of professional historians of computing. I've engaged with that somewhat in the course of putting my lab together, and they've been very good at saving stuff kind of randomly around the web on a bunch of different archives and repositories. They've saved a lot of executables, a lot of documentation. If I need a piece of software or a driver, I can usually find it, although it's kind of scattered. I suspect that over time, though, that community is going to kind of peak and then dwindle, because it seems like people are interested in the computer systems of their youth. So the same kind of way that Elvis memorabilia got really expensive and then crashed when the generation of people who cared about it weren't in a position to buy it anymore. I suspect that over time, the retro computing thing is is going to fade somewhat. So then you've got scholars, and there's three, I think, obvious groups of scholars. People writing history within computer science, right? Technical history. And the problem is computer science, you may have seen Donald Knuth's complaint about this and my article, The Tears of Donald Knuth. Computer science really doesn't support that as a career, right? Traditionally, some computer scientists have got interested in that later in life as a kind of hobby or a retirement project. But particularly in the US, you can't make a career inside computer science doing technical history. And that might change in the future, of course. Then you've got people in digital humanities, you've got things like the critical code studies movement. So you've got people who are very excited about talking about the possibility of reading code and applying discourse analysis and Foucault to it and discovering racism and so on. One of probably the most tangible product of that movement is this entire book on a one-line program. But in terms of getting seriously to grips with larger pieces of code and developing the skills to actually read the program as opposed to the comments, that movement has not produced a great deal. And again, that might change in the future. And then you've got professional historians like me, our book ENIAC in Action, which I mentioned. And I think that's interesting as an example of trying to integrate close-up study of code and technical detail into narrative history. But so far, professional historians of science and technology have pretty much ignored the book, except David Guguli, who, the eminent Swiss historian. He's the only person to cite our supporting website, and it was to basically make fun of it and say, why is a historian doing this? It's like terrible. So right now, and over the next 10 years, if you're saying who is going to be making use of all this saved code, the answer is, I know, maybe museum and website projects, but not a whole lot scholarly. But of course, what's particularly interesting about this effort, I think, is large-scale archiving, right, of entire source code repositories. And if that stuff gets saved now, it's still going to be there in 100 years. So the point of saving it, I think, is the faith that eventually people and tools will show up to do something with it, right? Which right now don't exist. But if you save the code now, it will still be there in 100 years. And if you don't save it now, it's going to be lost very quickly. So it's feasible to save vast amounts of code now proactively in the hope that they're going to be useful later. And I think that's a reasonable thing to be doing. And just a couple of points on that. So one of them is the ENIAC code we studied, we didn't actually run, right? We could have run it. My collaborator, Marc, who did all the hardcore technical work, had an emulator, etc. We didn't have the numerical nuclear data, which is still secret, that would be necessary to fully run the program. But we could still learn a great deal by reading the code and studying it against the flowcharts and the design documents and so on. So we understand exactly what it did, even without running it. Now, that was an 800-line program, right? That approach doesn't scale directly to enormous modern size code. And it doesn't scale. And the question of what do we do with distributed systems that have online components is fundamentally difficult. But on the other hand, especially if we assume that serious work on this code is decades out, tools developed to work with large text corpuses and the so-called approach of distant reading, right? Of like looking statistically and saying, how are the patterns of these usage of word changing, or how is sentence structure changing over time on a huge historical body of text, already exist. And given the way that machine learning and AI tools are working, it seems reasonable to suppose that, aside from trying to recreate or run individual programs, having this entire corpus of code available to study things like what are the changes in programming style and practice over time? What different tools and frameworks are people using? How is the business of the code itself, the use of comments, the use of different frameworks and libraries and so on, changing over time? Having a massive body of data available for that kind of long-term computer-assisted analysis in the future is going to be incredibly important, I think, in understanding how programming practice and the use of technology has been changing over this time. And this clearly in retrospect is going to be an extremely important epoch of history in terms of the computerization of everything. And it's reasonable, I think, to suppose that future historians are going to care about this, even if present day ones don't.
Thank you very much. So let's just go briefly around all the other speakers. So if there are any reactions and your comments about the articulated comment that Tom made. So I would start with Claire Fox. Please unmute yourself.
Sure. I think that I might take a step back from what Tom is talking about and just say that I think that, I mean, to kind of go back to the original question of what is it that historians can do to support digital preservation. So I work with students at Yale who are engaged in work that is at times very tedious for them. They're collecting metadata about commercial software largely. And so as they go through the process of gathering that metadata, it's a lot of spreadsheets, it's a lot of data entry, and they can do things like listen to podcasts as they work. But I mean, just trying to get them to be interested in exploring software and exploring the work and exploring EaaSI as a system and as a community of practice, that kind of like meaning behind the work, I think is important to get them excited about what they're doing, even if it just gives them that little bit of extra something as they're doing the work, like the data entry work. And so, I mean, I would just say that even, you know, for historians to write books about the history of software and put students in the mindset of understanding the history of what they're working on and the kind of stakes of what we could lose is a huge service in itself.
Kat, have you got any comments?
Yeah, I think that it's wonderful to see the scholarly work that historians are producing. And of course, in scholarly publishing at large, many people have trouble discovering relevant scientific literature, relevant scholarly literature written by people with whom they're not already familiar. And so I would offer that making connections between scholarly publications, books, and other artifacts, especially like the website about related to ENIAC in action, I can see adding that website to the item for ENIAC in Wikidata as a, there's a property to connect interesting websites related to ENIAC in Wikidata. And so that could be, we could create a statement on the item for ENIAC that would open up an entire new pathway for people to discover that website and then hopefully also discover the book. And so the projects of the Wikimedia Foundation are quite high profile on the web. It would be wonderful if somebody added information about the book and the website to the different language versions of Wikipedia articles across the different Wikipedias on the article for the ENIAC. And so I guess I'm a big supporter of cross-pollination between the academic sphere and the sphere of wiki projects. And I think that wiki projects can be a great on-ramp for a wide audience to learn more about any topic that is covered in the Wikipedias or on Wikidata. And that I have seen and I have heard other people share with me stories about how they came across very interesting information by reading or contributing to projects of the Wikimedia Foundation. And so, yeah, I am always enthusiastic about seeing more and more bridges between the academic world and the wiki world.
Thank you. Hansen or Marc, do you have a brief comment on this?
Well,
sure, yeah, I can.
Oh, go on.
I'll go, Marc, you can go first.
To build on what Kat was just saying, yeah, I mean, museums, we're sort of at the intersection of these various worlds of, you know, academia, the public, patent attorneys, which, you know, IP is, that's a group that really does use collected software and hardware. So we're sort of at this crossroads, and I would agree that, you know, I mean, I guess I see it as kind of a 360 view. You know, you have an important piece of software, you want to be able to link to both a close kind of reading of the code and also more, you know, public facing experiences around it, things that talk about its social role, what it actually means to people, you know, and there's a whole set of dimensions that are very important to cover. So historians looking at the nitty gritty of the code are one part, but there's also historians looking at, you know, what are the features in a particular system and how did they spread and how did they affect other systems and the people that use them. So I think, you know, I see it as we're sort of at the crossroads. We do, you know, for instance, we're using Wikidata for our open CHM to interface with other institutions. So, I mean, it's you know, all these dimensions are hard to predict, as Tom said, you know, what will people do with this decades from now? But obviously, if we preserve it, it's available. And I do think there are a number of fairly clear uses, and not all at the level of looking deeply into the code.
Okay, Hansen, do you need to add anything or?
Yeah, I guess I want to respond more directly to Tom, the discussion that Tom started. You know, I guess I see, you know, we at CHM, we preserve both source code and also executable software. And, you know, both of those are interesting. I see them as slightly different purposes. You know, so executable software would be, you know, the use case would be, you know, to be able to run that software, right? And so in a platform such as EaaSI, and that would be, you know, for somebody to do kind of like a, you know, like an ethnographic, you know, study of how a piece of software was used, what it was used for, you know, who it was designed for, that kind of a thing. Source code, you know, really, source code really comes in the form of text, and you know, we have a number of source code releases that, you know, most of our source code releases are actually of proprietary software, not free and open source software like the Software Heritage Project is aiming at. And you know, part of the vision of the source code releases has always been in the past, at least, driven by the idea of Len Shostak, who is, you know, the founder of the Computer History Museum, at least the West Coast version, as a way for practitioners, for computing practitioners, to learn something from the history of computing, from historical software, that they could possibly apply to the creation of new software or the solution of new problems. Because, you know, one of the things that motivated Len when he was creating the Computer History Museum is that he had been teaching a computer science course at Stanford, and he had noticed that the students there did not have an adequate understanding of computing history. And that's probably even more so today than before. And so, you know, part of his motivation, you know, and he was heavily involved in a lot of the previous source code releases and getting all the legal agreements signed with various companies, which can take like up to a decade sometimes. So, you know, that was Len's idea. Now, to what extent has that actually borne out? We unfortunately don't have the data because we haven't tracked, you know, who the people who've downloaded the source code are in the past. Moving forward, with two upcoming, you know, we have several upcoming source code releases that we're going to be presenting this coming year in our sort of new Art of Code theme. And these include PostScript and Lisa. And we know that Lisa in particular is going to have a very large audience of just enthusiasts and hobbyists and retro computing people out there, because there was already interest. The idea that we had acquired that code had been leaked several years ago, and that leak itself went viral and was discussed on forums and even in like the technology press. PostScript less so, but I would say that going forward, we're going to be trying to collect data on who is downloading the source code. So hopefully we'll have a little bit more of an understanding of who these users are and what they're doing with it.
Yeah. So let's go back to something that Tom anticipated at the beginning. So the idea of runnability. So one of my questions is, how much is important that software can be run, and how much it is important that can run on an original machine or on an emulator, and what are the issues for each of you? So for the historian, for the digital preservation, and for the museum curator and software storyteller. So I would start with Tom, if you can just briefly reintroduce, because I didn't expect a very strong view of the strong view we gave on runnability on historical machine only. So please, if you want to elaborate on that.
Yeah, so obviously emulators are important and enable certain kinds of historical investigation, right? At the same time, I feel that for teaching purposes, if we're in a situation where we're dealing with machines from, like the Apple II, the original IBM PC, the early Mac, which are still relatively easy to find and get running, that for teaching purposes, using the original machine gives you a completely different experience from using an emulator. And I found that undergraduate students today, right? I mean, when people were writing history of computing books, the classic texts like Campbell Kelly Asprey Computer, Saruz's History of Computing, in the 90s, they assumed that people still knew and remembered what an Apple Mac and an IBM PC and MS-DOS were like. And for modern undergraduates, they don't have that experience at all. So instead of starting to feel that the history of computing is becoming familiar and relevant to them in the 70s, they basically only feel that when they get to the iPhone. And if you bring up a machine emulator in a window in a modern computer, it's a very different experience from sitting down in front of it with the CRT display, seeing the floppy disk flop. I mean, the number one thing people say in my lab is, oh, that's why they call it a floppy disk. Putting it in, hearing the grinding and the whirring, seeing the screen flicker and so on, you get an experience of what it was like to use a computer in the 70s or early 80s or early 90s. That is very different from what you get with an emulator. And I mean, people experience software not in isolation as code, they experience it as running, right, in a particular embodiment, a particular materiality, a particular social and cultural context. And certainly for the purposes of non-specialists, I think they find it easier to relate to the materiality, as a way of getting a sense of the experiences of people in the past. That's a whole different set of motivations from the software heritage project, though. I think that goes with conveying the history of computing to a broad audience or non-specialist students.
So Claire, I think you might want to comment on this.
Yeah, I mean, I absolutely agree with Tom that it is a completely different experience to be able to access source code or legacy software using legacy hardware, a legacy machine. It's a completely different embodied experience. And it's one that, you know, I mean, I can even think of just like the impact of being able to see photographs of people working on legacy hardware. That in itself has an impact, even if you're trying to access software like via an emulator, especially on a web browser. You're accessing software in an environment that is already familiar to you as a contemporary user, and just being able to have access to ways to kind of even access some of the versatile, having ways to access that feeling of being able to see what a legacy machine looks like, let alone be able to have that tactile experience is really important. But at the same time, I mean, within the EaaSI program of work, our primary kind of goal is to provide access to legacy content and to legacy software. And so it's not as important to us that a user, or it's not a requirement to us that a user would be able to access software using a legacy machine. Our primary goal is to provide remote access to content and to provide access as far as to as many users as we can, to as many library patrons as we can. Yeah, I guess I'll just leave it there.
Thank you. Any other quick comment on this?
Oh, sorry, just to say the legacy machines are short duration. I mean, we have 2 restorations at the museum, the IBM 1401, PDP-1, and there's, you know, very serious teams of volunteers required for each one to keep them going. Macs and PCs are still relatively easy to run, but I mean, you don't have to go very far in the future when this is like, you know, how many 1850s steam trains are still running. I mean, it just gets harder and harder. So obviously emulation is going to be the primary method. And I kind of see it, you know, it's like there was a time when, let's say 500 years ago, people were like, if you can't read it in the original Latin, it's not worth reading. And then they did these, you know, translations into other languages. So sure, you can take the purist point of view that it is really a different experience with the original machine, but that's simply not going to be accessible very broadly. However, there's one, you know, people have been talking about virtual reality a lot for 30 something years. Vermal VRML for the web was supposed to bring it a long time ago. But at some point, this is going to get more common. So why is it that you cannot have the experience of using, you know, an original 128K Mac where you're constantly switching floppies in some sort of virtual environment? So I do think that, you know, we're going to lose the original hardware, but we're also going to have better and better tools to experience, you know, to have that kind of embodied experience, not just for computers, but all sorts of things.
Thank you.
Yeah. Yeah, I can also jump in as well. You know, I see both sides of it as well. You know, from Tom's to Tom's point, you know, there is something that you get with the materiality of working with an actual machine. And you know, I grew up during the PC era, so that part is familiar to me. But I had never used a mainframe or a mini computer before, and you know, probably the vast majority of people attending this conference may not have done so either. So, you know, when I had first came to the museum and was, you know, saw the 1401 restoration, you know, it was immediately evocative to me because of not just the sight of the machine working and seeing it work and you know, punching the paper tape and all the punch cards and all of that, but also hearing the, you know, the sounds of the, you know, the line printer, and then just the smells, right? And you know, Marc talks about, you know, VR and the metaverse recreating this kind of a thing. You know, I don't know if the metaverse will recreate smells. Yeah. you know,
they're
maybe in the
working
Brave
on
New
it.
World.
Hansen, they're
Yeah,
working.
they're working on it.
There's
Yeah.
Taste Your TV. You can send taste.
Well, I don't know how the, you know, how they're, you know, how would they know what the 1401 smells like, and how will they recreate it unless they have a real one to, you know, to help recreate that smell, right? So, yeah, you know, but anyway, but you know, but to Marc's point, you know, how long will we be able to maintain these things? You know, it is a dedicated team of people, of volunteers, older volunteers who worked with the 1401, who are maintaining that system. And once that generation of people passes, that knowledge will be lost. Like, there's a lot of tacit knowledge, you know, a lot of practical hands-on knowledge. And, you know, there may be one or two people, you know, in the younger generation who are, you know, interested in preserving these sorts of things, you know. So like with the Apollo guidance computer, there was, you know, one young engineer who was, you know, helping with that effort. And, you know, similarly with the Xerox Alto, you know, there was an engineer at the Living Computer Museum, Josh Dersh, who was who wrote the Alto emulator. And so he's very interested in preserving this kind of thing. But how many of those people are there? You know, there are not that many. And, you know, so going forward, we, you know, again, to Marc's point, at some point we may have no choice but to emulate in order to preserve the experiences of running these computers. And yes, it's not the same thing, but it's the next best thing. And it's, you know, and if you're looking at 100 years out, that there may not be an alternative. The original machines may no longer run. The CRTs that, you know, that you could connect to an Alto are no longer being produced. You know, there's a limited lifespan to all of these.
Thank you. So, Kat, do you have any comment?
I also agree that my memory of walking into a room where a single computer was stored, and just understanding the scale of the physical hardware from a historical period is impactful and an experience that you can learn from. From the perspective of somebody developing an application like Software Heritage Stories, emulation is something that we can include in a story, whereas the experience of running the software on the original hardware is not something that we're going to be able to recreate in a web experience, other than maybe a video of that happening. And we would love to include videos like that. So I think that emulation certainly is crucial for software preservation, because it can be presented on the web and thus reach a lot of people who may not get to visit a place where the original hardware is being preserved and housed.
Okay, I'm gonna tackle another aspect of software preservation, and then I'll open up the discussion to the public. So I'm gonna ask you to be very brief if in your comments, if you have any, because we've got 15 minutes left. So I would reflect now on the software preservation paradox. So who preserved software preservation? So preservation project may rely on unsustainable funding or institutional support that may cease, discontinued platforms. Preservation project may fail to preserve themselves and evaporate when the project ends. So what is your view on this, and what can we do about this? I would start with Claire.
I think I'm still the answer there, but also who preserves software preservation? I mean, I think that a lot of this probably comes down to the sort of generation and support of a community of practice. So when it comes to thinking about like what is a sustainable system to support over time, we all know that a lot of the systems that we use today are going to be deprecated. We're storing data in places where support might not be offered in the long term, but if we develop relationships with other people, that gives us the capacity to kind of keep doing this work and keep pushing it into the future.
Marc or Hansen?
The Internet Archive preserves a lot of software. We do. Hopefully both those will last for a long time. Some national libraries are preserving web data, but generally not software per se, as far as I'm aware. But, you know, hopefully this will spread more to become the way people preserve literature.
Yeah, I mean, hopefully the platforms will eventually consolidate. Right, archives will get archived into archives. Maybe it will finish up in the Internet Archive or wiki platforms. But I think once something has been captured and you know, sustainably and carefully preserved, it would be much easier to roll that into a different repository. But I mean, I guess in general, the issue is if this is a kind of archive, right? Archivists usually have to be very selective and they make guesses about the things that are going to be valuable to historians and save those things. And traditionally, archivists can only save a small fraction of the possible number of collections. Within collections, they have to prune the material. And with these digital tools and essentially unlimited storage, we're in the position that it's actually easier to save everything in terms of a repository than to try and be selective. But as I mentioned earlier, we're also having to imagine entire communities of users coming to existence in the future who will make use of these historical sources that don't currently exist. So that's a quite different set of challenges and opportunities, I think, from those faced with more conventional kinds of archiving.
So thank you. So let's open up the discussion to the public. I'm seeing there is a lot of traffic on the chat. I was possibly started by Paul Ceruzzi at some point. So let's start with the. So is there anyone in the room here that has a comment or a question to ask? Okay, so maybe Paul would like to comment. Paul Ceruzzi.
Can I unmute myself? Is that allowed?
Absolutely, you are allowed to intervene. Okay. Yes.
Here, you can even see what I look like. Whoa, although, whoa, anyway. Yeah, I used to work at the Air and Space Museum. It was the most popular museum in the country and one of the most popular in the world. And people go there to see rockets and airplanes. I don't think they go there to see code. And we talk about this all the time. We collect a lot of things, but a museum really should be a place that shows things to the public, in my view anyway. There are institutes, the Charles Babbage Institute and the other institutes that are on these panels today that have, they are open to scholars and people who have a special interest in the subjects. But the public, it's obviously very, very important to me that the public be educated in some way about the place of code in the world today. Don't ask me how to do that, but it's a challenge. But I would say museums are probably not the right place for it. It's a bit controversial, but that's my feeling anyway.
Okay, so is there anyone from MO5 that was contributing to the online discussion in the chat there.
Yeah, I had a comment that responded to that. Yeah, like, so, Paul mentioned in the chat that, the Computer History Museum is the exception that proves the rule. And I think that's somewhat accurate because we preserve source code more as part of our archival mission rather than as part of our museum exhibition function. So it's really for researchers and scholars to look at the source code. Then as something that we put on an exhibit. Now there is a small amount of Photoshop source code in our Make Software exhibit, part of the Photoshop exhibit. There's actually to what extent though that like that code is there for the kinds of purposes that like Tom was saying, software studies and all that. That not really. And there's actually a funny story about the code. When we originally put a code up there, it was actually incorrect. So it was, we had put code up that was, it was actually the sort of a resource code, but not like source code. So not the kind of code like, so it was an old Mac program, right? For Photoshop 1.0. And it was, so what we were showing was the code that was making up the resources, like the icons and menus and those sorts of things. And then an engineer at Apple pointed that out to me after he'd visited the exhibit. And so then I went back and I went back and we replaced that code with the actual source code of the menus. And so now if you go and you see that part of the exhibit, you see the source code that shows the menus. And we chose that partly because we wanted to show something that people could actually recognize what that was, right? That users would see, oh, this is a menu. I know what a menu is. I know what a menu looks like. I know what the menu bar of Photoshop looks like. That's something they could actually understand. But that took some effort to find something that was somewhat understandable. Most source code is completely, unintelligible to the public. And, we're actually, in our upcoming Photoshop release, we were thinking about recording, say a video of me looking at the source code and discovering interesting things about the source code. And I took a look at the source code beforehand and I couldn't make heads or tails of it. And, I had a similar experience when I had first looked at the PowerPoint source code that we had as well. And, one of the interesting things about it is I do think it's very, very difficult for someone to understand a large scale code repository without a document or describing the architecture of that code and the way that software was designed, and the way that the pieces, fit together, the way that the different files interact with each other. Like you could eventually figure that out, but it would be a long-term project to reconstruct that. But if you have the people who wrote the code still around, they can maybe help explain it. However, sometimes the people who wrote the code don't even remember. People sometimes, our PostScript code is 40 years old. It's 40 years old now. And, we're trying to engage with the people who wrote that code back in the day to help us explain it. And some of them don't even quite remember what it did. So it's, even in that case, developers talk about writing comments for their future selves so that they can understand what they wrote just a year ago, right? This, even developers know that they won't remember what they did just a few months ago or a year ago. So expecting somebody in the digital humanities to understand what a piece of code is doing in a language that they may not know, that may be a stretch. And a lot of the code that is out there, a lot of probably a large percentage of code in a lot of software is just boilerplate. Is pretty repetitive stuff that a lot of other software has. Reading and writing files, that's not rocket science, right? Nobody cares about that part. for Photoshop, what we care about are the algorithms, to draw the graphics, right? Those are the interesting parts, and so how do we find those interesting parts, those unique parts that are part of the source code, rather than the millions of lines of boilerplate code that are replicated across many other systems? That's an open question to me.
Yes, so we've got 3 minutes left. So I see. So, Marc, I can give you 1 minute.
Oh, just to say that, I agree with Paul that source code is probably not what you want to show directly in the museum, but we often will show things just one level removed. Like, for instance, for the MP3 algorithm, we have a thing you can listen to the versions before Karl-Heinz Brandenburg got it right. So, you're sort of engaging with that algorithm as a sound. Also, a lot of these things come in as even museums, we do blogs and events and various other things. And we also work with various journalists. So like, we helped with a story that the History Channel did on the release of the web, the World Wide Web Library in 1991. And that's really a code story, but it's also a very human story. So there's those levels where it's just one step removed from analyzing the code line by line that I think are very accessible to the public.
So thank you. Would you like to add anything?
Well, I'm afraid I'm one of those who have been so well, anyway, there's 2 things I'd like to comment. First of all, I remember, every time I'm doing some teaching in programming, I'm one of those teachers who says, your documentation is way worse than your code. In some case, forget your code, do the documentation. Somebody will do the code for you. Well, anyway, there's something interesting, I think, that Hansen and yes, I think Thomas, who have pointed out, it is people need to be guided to use all computer. And well, this is a remark. I don't have some specific view on it, but in MO5, we have 2 kinds of people who are using our computers. They are our members. These are educated people in all the computers. Those ones don't need to be guided in using this computer. But we also present it to the public. And actually, when doing so, the computers or the consoles we are showing are already up and running some software. And so there's no problem in usage. But it seems to me that Thomas and Hansen are much more presenting all computers to some public to educate them. So it's just not just one program that is running on the computer, but they have to learn how to use the computers. That's it.
Yeah, I mean, that's right. My course that I use the lab in so far is for non-specialist undergraduate students, I guess between the ages of like 19 and 22. And they can read about personal computers and the kind of applications people had and so on. But I think they get a very different kind of understanding from the experience, say, of sitting down with a BBC microcomputer, opening the manual, putting the welcome tape into the cassette player, pushing it, having to adjust the volume to try and make the computer load the thing. And so in some ways, the big picture question is, why did everybody in the 80s suddenly decide they needed a computer in their home? And in some ways, if you actually look at it, it's more mystifying because it doesn't tell you, it just assumes that you need to know about computers. The manual starts out with, congratulations, here's your computer, here's how to make your thing work. And then it teaches you programming. And so students have to kind of answer this question, why in that time and place did people believe it was important to learn how to program in BASIC to the extent that they would go out and spend a large amount of money and put a lot of time in with this thing. And then they can also see how, but look at all these games. So then they read about the video game Elite and they can play that on the original hardware and so on. And then that, I think, gives them, again, just a whole different kind of experience. Just from reading in a textbook that these things happened, they can begin to, you know, try and understand the experiences that people were having.
Thank you, Tom. So we are really arriving at the very end. So I've seen a lot of activity in the comments, in the chat, that hopefully we'll be able to share with you along with the recordings. And one of the things I managed to read while listening to all of you was also Roberto's comment about computer literacy and the ability of newer generations to be able to understand a bit more about source code. So I will leave him to close these 2 days